Hello, and welcome to part 3 of porting the elemental shields to Sonic 1. So in the last part we ported the remaining elemental shield abilities, namely the electric shield attracting rings and the bubble shield preventing you from drowning. Now in this part we're going to do something a little less flashy. This is something that will actually have a visible effect. You see, Sonic 1, while not the most advanced game on the Mega Drive, is kind of putting the Mega Drive to its limit. You see, things need graphics, right? The elemental shields need graphics, and, well, there ain't really any room, and I ain't talking about the cartridge. So if we start up Green Hill, pop open the VRAM debugger, you'll see, looks pretty full. So, I believe if you look here we go, you can see the graphics for the regular Sonic 1 shield, and here you can see the graphics for the invincibility stars. Gee, wouldn't it be nice if we had room for Sonic 3 shields, huh? I mean, this is just Sonic 1's, and it takes up the year room. Imagine how big the fire shield is, or the bubble shield, or the electric shield. You might see why this is a problem. So what are we to do? Well, first we need some room, obviously. But that room won't be enough. Because as I said, Sonic 1 shield only has a couple of frames of animation, but fire shield, bubble shield, electric shield, they have a lot. So, we'd have to tackle the mere fact that even if we freed up some room, it wouldn't be enough room. But let's take things one problem at a time. Where are we going to find room? There ain't any. Are we going to just start pulling things out, maybe unused assets? No, let's not go that far. Instead, well, let me bring this back up, just for illustration's sake. So, you saw, in VRAM, the shield and the invulnerability stars, or invincibility stars. But here's the thing. Sonic neither has a shield, nor is he invincible. So these graphics, at the moment, kind of are unused. Yeah, we can run ahead and grab the invincibility star monitor, and well, now the star's being used, sure. But they weren't being used earlier. What if I go and grab a shield? Okay, then I'll have a shield. But there is one other thing to consider. It's the fact that you can't have, or you can't show, a shield and invincibility stars at the same time. So that means at any one point, only the shield or the invincibility stars need to have their graphics loaded, and sometimes neither need to be loaded. So you might have figured out what our little tactic is going to be here. I'd really like to show this before moving on. Come on. I'm not sure how many people actually know this, really. I mean, how many people get invincibility while having a shield and actually notice the shield goes away? Oh, yeah. Got an electric shield. Cool. Forgot I was even playing a mod. Hack. Anyway, so pop open the monitor and there you go. The shield's gone, even though I technically have it. Although I can't double jump. Huh. I mean, this is such an edge case, even I forgot that happens. So let's see what happens when the invincibility goes away. Again, can't double jump. So the stars go away, shield comes back, and I can double jump again. So I guess the invulnerability stars pretty much just disable the shield. Weird. Okay, so yeah, that's what we're going to be doing in this part. We're going to be converting Sonic 1's shield and stars object to dynamically load their art. In effect, will free up a whole bunch of VRAM, thus allowing us in the next part, hopefully, to insert the elemental shield graphics. And yes, Sonic 3 did have this idea. In Sonic 3, not all of the shields are loaded at once, only the one you currently have is loaded. So we're merely just converting Sonic 1, updating it to Sonic 3's methods. So where do we begin? Good question, actually. I suppose the first thing to do is, well, give a quick breakdown of how Sonic loads its graphics in the first place. The majority of assets are loaded either before the little title card for the level appears, or slightly after during gameplay. When that happens, the graphics are usually the ones stored in what we call Nemesis format. It's a compression format. Nemesis is kinda crap. Its compression ratio is bad, it's slow. I think its one upside is that you can decompress it directly to VRAM, whereas the other compression methods like Kaczynski, no they don't, you have to decompress to RAM and then transfer them over. Sonic 3, when coming up with this method for the elemental shields, had to compromise and basically use no compression. Because Nemesis is slow. Not slow enough to lag the game, no, it's slow because Sonic Team didn't want it to lag the game. You see, Nemesis uploads, what, maybe 3 tiles per frame? You might think that's quick enough, but no. If we use Nemesis and decompress the shield graphics, let's say, there will be a frame or 2 or 3 where the shield just displays garbage data, and it may be a couple of frames, but you'll see it, trust me, so that's unacceptable. No, rather that you have to decompress the graphics, leave them on the cartridge, and then just upload them to VRAM, hopefully within 1 frame. Well, it is within 1 frame, it will halt the CPU. But do we really want to do that manually? Do a little for loop manually uploading each byte to VRAM? No. No, that's slow. The Mega Drive actually has a special little hardware feature called DMA, Direct Memory Access. It's basically the Mega Drive's graphics chip, the VDP. Instead of the CPU uploading data to VRAM, the VDP will fetch data from the cartridge, and according to Sega's documentation, it's pretty much twice as quick as getting the CPU to upload it. So in the name of good performance, we're going to want to use this fancy DMA thing, but well, I mean, come on. Who here knows how to initialize a DMA transfer? Not me off the top of my head, that's for sure. So rather than worry about that, we have 2 options, I suppose. Because this DMA thing doesn't exist in Sonic 1. Sonic 1 does not use dynamic DMAs. It uses hard-coded ones, but I ain't in the mood to hard-code some DMAs, let me tell you. So for Sonic 2, they introduced something called the DMA queue. It's a pretty streamlined thing. You just pop off commands arbitrarily to say you want to upload this to VRAM. Then later on during the vertical interrupt, the game will initialize the DMA for you and upload it directly. So we could port the DMA queue from Sonic 2, but I don't want to. It's slow, it's limited, and there's just better homebrew stuff out there. So we're going to take a break from writing our own code or porting code from Sonic 3, and instead we're going to implement a little homebrew code. Well, I guess it's not entirely external. I mean, I did kind of help write it, but okay, so we're going to want to go to GitHub. Here we go, the Ultra DMA queue. The licensing is pretty liberal, you can basically do whatever you want. Don't even need to credit. So yes, we're going to be embedding this in Sonic 1 and using it to dynamically upload the shield graphics and the invincibility graphics to VRAM. Seems like a little bit of a minute task, who knows, maybe this part will be shorter than the others, but, well, I've seen how that train of thought goes. Not well, is the answer. And of course, there are no installation instructions for Sonic 1, just for Sonic 2 and 3. So we're going to be doing a little guesswork. Now, unfortunately, the DMA queue is not something you can just wedge into the code and magically have it work. No. It's one thing to call the DMA queue for the purpose of putting something in the queue, but then you need the game to automatically pump that queue, process them, and respond to them, perform the DMA transfers, and so on. And off the top of my head, I don't recall how to do it, so we're going to be doing a little bit of porting from Sonic 2, the closest ancestor to Sonic 1. I don't think Sonic CD has a DMA queue. That thing... Why did that thing flop in the programming department? I mean, what do you expect? They didn't have Yuji Naka on hand. Anyway... let's have a quick look at what's going on in here. Oopsie daisy. As you can see, this DMA queue has a lot of options. They're mainly security and flexibility for speed. I mean, the point of this is to be really quick. Now let's see, source address in bytes. Yeah, okay, I think we can safely disable that. This all like adjusts the API, but because we control the usage of the API, we'd have to worry about API compatibility. I think this is by default configured for Sonic 2, which uses a less than ideal API. It's tricky to explain. Basically, the VDP sees everything as a... well, it counts everything 2 bytes at a time, which is pretty weird. But the average program will count in bytes, single bytes. So the number you pass to the DMA queue has to be divided by 2 for the VDP to understand it. And this just says assume it's in bytes, or don't assume it's in bytes in this case. Just save just a little bit of speed. Just 10 or so cycles. Hopefully, we'll have to worry about RAM source DMA and all this other stuff. Let's just hope it works first try, huh? So, I suppose we're going to have to look at Sonic 2, which I don't have downloaded. Oh dear. So let's take a peek. What am I doing? That's Sonic Retros. Sonic 2 disassembly. Why did I say retros? Ah, goody, the internet's down. Well, okay, and it's back. And I have to type that all over again. Okay, where was I? Alright. I believe the function we're interested in is called QDMA transfer. Yep, there it is. So as I said, this Q gets pumped. Oh, right. This is just the Q function. We want process DMA Q, don't we? Here we go. So this will be called during what we call VINT, vertical interrupt. To those that don't know, it's essentially a bit of code. It's almost like a thread, really. But it's not asynchronous, no. It's an interrupt, it pauses, it's one CPU. How the... Let's just keep it simple. It's a bit of code that's ran 60 or 50 times a second. Either at the beginning or the end of every frame, depending on how you look at it, I suppose. So it's that which pumps the DMA queue. So here we go, this is VINT code, definitely. Here we go. Now, the way Sonic's engine is laid out, is like, here's the main VINT, and then you can set a flag, and that will trigger a different little sub-routine to run. Some of them pump the DMA queue, some of them don't. Like the Sega screen apparently does not use the DMA queue, so it doesn't pump it. The little PCM subroutine thingy, no. Title screen, no. Which is interesting. But the level, of course, the levels do. Why? Because in Sonic 2, Sonic and Tails use DMAs to upload their sprite data. Or should I say, use the DMA queue to upload sprite data. Again, Sonic 1 does use DMAs, but it hard codes it. So levels do it. What in the world? Ah, the special stages use it. I don't recall what this is. I think this one might be unused. Oh, sorry. I think this one went unused in Sonic 2. It's a wee little leftover. The title card uses it. Okay. Don't really know why that one does. Well, what am I talking about? This is Sonic 2. Never mind me. Anyhow, yeah, the title card uses it. The ending uses it. Menus, yeah, for the background, I think. And then it stops. So I think we can actually get away with doing this by hand, really. Because it does make sense, you know, the levels do it, so do it in the level. I had it in my head that Sonic 2 did it pretty much everywhere. But no, it really does seem to be a need-by-need basis. There is one thing you should remember, though. See this? Stop Z80, start Z80. The Z80 is just the name of the Mega Drive's other processor. We're running all this code on the main processor, but there is a second one. There's a hardware bug, apparently, on very early Japanese models, where somehow, if the Z80 is running while a DMA transfer occurs, there's some kind of memory conflict, RAM gets corrupted. This is all hearsay. I believe I heard this one from Natsumi? Greensnake, Aurora Fields, whatever the hell the name is these days. So you should keep that in mind. As we're adding this, we're going to be halting and resuming the Z80. Because we do not, might as well try and be compatible with the original hardware here and just follow Sonic Team's example. I'm sure this is mentioned in the dev documents that are floating around the internet. So, let's get on with that. I believe Sonic 1's VINT code is still inside this main file. I really hope so, because boy do I hate the Sonic 1 disassembly split layout. It's just annoying. I mean, I wind up searching a giant blob file anyway. And yes, I do, write C programs with multiple source files. The difference is my source files in my C projects actually make sense. Okay, well, I think this one calls it VBlank. Yeah, there we go. Going against the grain here. As you can see, it's the same structure as Sonic 2. They have the same engine after all. Don't appear to be documented. Like, what the hell is what's 12 for? No one knows. This is why I prefer the Sonic 2 disassembly. Look how good this is compared to Sonic 1. I mean, yeah, okay, and there's no comments. Okay, but hey, the code speaks for itself. There are no unequated RAM addresses. Alright, that's enough ranting. So, there's probably a title screen. No? Is it the level? I don't know. Whatever. As you can see, we do have stop and start macros here. Right, VRAM is probably doing some kind of DMA. Or maybe not. So, since the elemental shields are only in gameplay, I suppose we should just limit ourselves to the main level routine for now. If we go back, not that far. Right. As you can see, it occurs pretty far down. We can't anchor ourselves to this because this isn't in Sonic 1 either. Hang on. So V sub 8. Oh, it's the lag one. Okay. So we want to go to 8. Alright. So uploading the sprite table. That's Sonic sprite data, sprite table. H scroll buffer. Yeah, we're here. Okay, this is just uploading Sonic's graphics. As you can see, yeah, like I said, Sonic 2 uses the DMA queue, but Sonic 1 hardcodes it, so here is Sonic 1's explicit code. Right, and right under here, we're just going to call... sod it, I ain't in the mood to go back and extend this when the assembler inevitably starts complaining that the count's too far away. Okay, so now we just need to include dmaq.asm and then start using it to, well, you have to convert the shield and the invincibility stars, then upload their data using QDMA transfer. Of course, that's just one way. Flamewing's DMA transfer implementation, I guess, does provide a macro which is a bit quicker, but I can't be bothered to figure that out right now. It doesn't seem to me that this function is documented. Or maybe I'm going crazy. Ah, okay. One more thing. We do need to initialize the DMA queue. You know, I'm a little puzzled now. I'm starting to remember, I swear Sonic 2 had something like this as well. So on top of pumping the queue, we also might have to arbitrarily clear it. Well, we do have to initialize it. Okay, what the hell? I don't know. I guess we'll just have to look at the Sonic 2 installation guide later and see why this one has a reset. I know why it has an init. I'm kind of the guy that added that. Well, not added it, but I added a thing that's one of the reasons this is a thing in the first place. So let's take a trip to the game's initialization and quickly call that initialization function. The proper place is right before the game loop. Here we go. This is probably good enough. Initialize DMAQ. Let's be real. It's going to be a JSR. It always is. Okay. We'll worry about that later. Here we go. Proper documentation of how you call QDMA transfer. But I suppose we can't worry about that yet. For now, let's just get the code to assemble, which it won't right now because there's no code. It's not been linked into the program yet. Now, where does this game keep the generic middleware? I swear there was one place where it just kept generic Sega middleware right near the top of the ROM. Maybe I'm going crazy. Let's just take a look at the nearby stuff. Like, here we go. Read joypads is right next to it. That sounds good. Clear screen, sound driver, and I'm back here. Fantastic. Alright, let's try our luck. Let's just include it here. Okay. Oh, right. We need to allocate some RAM for the DMA queue. Oh dear. Alright. So where can we find a bunch of spare RAM? I know where. Sonic Retro. Ah, right. My internet's... Okay, it's not my internet. Jeez, I need to be more careful with URLs. So we need a reasonably large RAM buffer. That looks pretty good. Yeah, a nice buffer of 40 bytes will do. Here's a buffer of... Okay, no. Oh yeah, I remember this. For the longest time, people thought the sound driver used 600 bytes, but no, it's just 5CO. Okay, well. Yeah, this'll do. For a second I thought I was going to have to do some crazy stuff like remove Sonic's art buffer in RAM, but no, this'll do. Okay, so we will, since we're not hating for RAM right now, we'll just allocate all 40 bytes. This will round it for us, I suppose. Maybe not. If I recall, band buffer slot is a word. Yep, it is. In Sonic 2 it's a long word, which was really, 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 really stupid. So... we're just going to set this to, I believe, 5FE. Sure, that'll do. Again, hopefully, the DMAQ code will just figure it out on its own. Okay. So, will the game blow up? We've initialized the queue, we're pumping the queue, but we're not actually putting anything in the queue. We've got RAM allocated for it. It's assembled correctly and the game seems to be running just fine. Cool. So now on to the hard bit, converting the graphics. Okay. So, unfortunately, this isn't the kind of disassembly where the assets are uncompressed and they just get compressed when you build the ROM. I suppose that would have made the build process more complex, but adding to the problem, we don't really have any accurate compressors for these files. We haven't fully reverse engineered how Sega's compressors would have worked and produced identical files and blah blah blah. So, we're going to have to decompress these. Where are they? Have I gone past it? Jeez. Here we go. So we have the shield, and if we look for invincibility stars, these both need decompressing, so that we can just upload them straight to VRAM with no slow compression in between. But what decompressor to use? There is a lot. A massive problem with people just not understanding this kind of thing. People will use the most outdated tools out there, maybe because the wiki recommends them. Either way, don't trust this wiki all the time, for goodness sake. I remember this one time, who the hell were they? Some trashy trivia YouTube channel read word for word a completely incorrect Sonic Retro article on the Ashura bug. Yeah, you could have consulted a real Sonic hacker, but no, you just read some bullshit on the internet. Oh right, it was Did You Know Gaming. Twats. Okay, so, you want a good compressor, or good decompressor, something intuitive to use on Windows? Well, you'll want the Ken C shell extension, made by Main Memory and yours truly. And yeah, it's just a Windows shell extension, it makes this stuff easy. The rubbish tools on Sonic Retro's wiki that everyone seems to use, yeah, they're very clunky, this ain't. And it's a better compressor, smaller files. Yeah, there I am. I can assure you there's no virus. Go compile the code yourself if you're not sure. Okay, and with that, if I wanted to decompress these stars, all I gotta do, come here, come to Nemesis, and decompress. If I just hit refresh, there we go. The uncompressed version is right here. So let's get rid of the original. Quickly put this in the art unc folder. There's not actually a need to do this. It's just, you know, nice. It's better formatting. Now we want the shield. And there you go. So now we're going to want to decouple the old Nemesis compressed art from the game's art loading system. Knowing my luck, it's spread across 10 different files because this disassembly is just the absolute worst. So I'm going to be using the good old listing file, so I don't have to scour a million files. And we're going to look for artnem dash. Let's start with the shield. So here it is. Oh wow, they kept right next to each other. How convenient. Yeah, here it is, the pattern load queues. They're just kind of blobs of files that get loaded arbitrarily. In this case, I believe it's right when the level starts as opposed to after the level starts. Okay, anywhere else? No, that's it. Okay. Interruption. Okay. Now where was I? Keep that just in case. Hey. There you go. Just gonna keep a copy of that handy just in case. Yeah, of course not. What is it? Ink pattern load queues. Yeah, here we go. So now it's just the monitor's out on its own. It actually, let's comment them out because, oops, because these here are the VRAM addresses. We're going to want to keep them because we need to know where we're going to load the data later, right? So that should be done. The art's now been decoupled. If we play the game real quick, you'll see that indeed the graphics are not loaded. Yep, completely blank. So if we open the VRAM editor, look at that. Completely empty. If I were to get a shield, that would be invisible too. So now I need to backpedal a little because we do need the art just in uncompressed form. So I suppose we can actually put this back real quick. Let's adapt the naming scheme just to suit the rest of the disassembly. What am I doing? And maybe shuffle things around. Okay, should be good to go. Now, we're going to want to add a call to the DMA queue in the, well, it's probably better if I just show you. Now, which one is the shield? I wish I could remember. Here we go. They're a shared object in Sonic 1. So, this is really stupid disassembly work. Because objects follow a pretty standard structure. You have this little offset table. It's basically the equivalent of a switch table in assembly. So case 0, case 1, case 2. These are offsets, not indexes. So, the normal terminology is that case 0 is called init, short for initialization, of course. Because it runs once and initializes the object, changes the routine so it's never ran again, and then it runs the second one forever. We call this second one main, because it's the main bit of code that's always running, and we call the first one init. But of course here, this being the best disassembly on the planet, calls the init one main, and the main one shield, or stars. Not very helpful, because when I say we're going to load the art in the init function, oh look, there isn't one, except there is. Passive aggression aside, yeah, we're going to load our graphics here and here, because each bit of code runs depending on whether it's a shield or a star. We don't want to do it here or here, because otherwise we'll be loading the flipping graphics every frame. Not good. So how do you load graphics? It's just a simple call to QDMA transfer. So if we quickly look up here, we again get a breakdown of the API. So D1 holds the source address. In our current configuration, it's the address divided by 2. D2 is the destination VRAM address. And D3 is the length in words, or 16-bit values. So, one little thing to keep in mind about D2 destination address, there are two ways to refer to VRAM, either by actual byte addresses or tile indexes. I won't go into detail, but keep in mind we might get this wrong and have to amend it. So all we have to do is set three registers and then call QDMA transfer. Let's hope this goes as planned. Shield specific code. Here we go. You see right here, this is a tile index, which just so happens to be the VRAM address divided by 20 or 32. It's 20 in hexadecimal. So if we come here, shield, that, and then there's this, which is that divided by 20 or 32. So let's keep on typing Z80 for some reason. What am I doing? So art shield divided by 2 to D1. Oh, right. There is one problem besides me failing to spell shield yet again. We're going to want to know how long the uncompressed data is. With compressed formats like Nemesis and the sort, the compression format will tell you how big the data is, but in our case we have to do it ourselves. So let's just bring that over here. So we have art shield, and then just at the end, art shield end. Now in complete fairness, these aren't needed. A tile is guaranteed to be 20 bytes long, which is an even number. 20 in hexadecimal, of course. Alright, let's cross our fingers. You know, I hate to say I told you so, but I told you so. We even put the DMA queue in the typical middleware region, and we still have to do this blooming thing. Always got to extend those branches. Always. Hey look, it didn't compile. Assemble. I'm very bad at this. Okay. Well, while we're doing this, let's keep an eye on that VRAM, huh? Get the mouse out of the way. Look at the game go. And that's how slow Nemesis is. You saw that, okay? You saw that scroll in. That's how slow Nemesis is. Meanwhile, not to get ahead of myself, but let's see how quickly the invincibility stars load. Just like that. Alright, so we did it. The invincibility stars are successfully loaded, only when they're needed, with no glitchy frames or anything. Of course, it doesn't have to decompress, and we are using a proper DMA transfer. That's irrelevant. Now let's get a shield. Does it load? Yep, no glitchy frame, no nothing. But, well, what was the point of all that? Now they're loaded. Yeah, well, smart ass, we still have one more thing to do. We're going to make them share the same VRAM address. So, you might have put this together already, but ObjFX here tells the game where to look for graphics. And when we're doing the DMA transfer, we're seeing where to put the graphics. So by changing this as well as this, we've said not only where to put the graphics, but where to read them from. So now the invincibility stars will read their graphics from the same place as the shield graphics. But because we have a proper system of loading these things back and forth, they'll work and they'll share the space properly. So, grab invincibility, and you can see it is now loaded to the shield area. Oh, right. Yeah, while also filling VRAM with garbage. Let's pause for a second. We made a mistake. This is meant to be divided by 2, because it's measured in words and not bytes. With a word being 2 bytes long. Silly me. Hey up, I want that little VRAM back. There we go. So yeah, chances are, as I'm running through the level, we're going to see some glitchy graphics. But as you can see, the shield then overwrites the invincibility stars. And attracts rings, because I've got an electric shield again. Cool. My favourite shield. Now I know there's an invincibility at the start of Act 3, but I don't really want to wait all day to get there. Let's restart and test a little an edge case. Well, if I get a shield, then while I have the shield, I get invincibility stars, then lose it and go back to having a shield. Does the object reinitialize itself? I'm pretty sure they do. Like, you remember, I had invincibility and I lost the elemental shield ability, so that means I temporarily lost the shield. Now I'm pretty sure the invincibility stars and the shield share object RAM. I could be wrong though, but we'll see. If they share object RAM, then of course to reinitialize the object RAM, the object would have to reinitialize itself, thus running the initialization routine. I've got another electric shield. Yeah, thus reinitializing itself, reloading the graphics, and working as intended. So, let's come back over here, grab an invincibility, and as you can see, the stars have loaded over the shield. That there isn't a glitch we introduced, by the way, that's the Mega Drive sprite limit. The invincibility stars tend to use a lot of sprites. Oh dear, would you look at that? Okay. Well, once again, just when I thought we could finish off this video, we have a bug to fix. Now again, yeah, we could load the graphics every frame, but no, that's rubbish. We need a proper way to determine when to load graphics beyond this initialization stuff. Here's some dead code, nice. Here we go. Wait, no. What am I doing? Okay. So if Sonic is invincible, it just doesn't render. Okay, but that still doesn't tell us what to do when Sonic goes from having invincibility back to having a shield. To tell you the truth, I think the last time I fixed this, it was with a sledgehammer. I know this is actually a little pointless because we're removing the original Sonic 1 shield, we're replacing it with the elemental shield, but still, while we're here, and because it shares logic with the invincibility stars, I think we should still do this the proper way. But what is the proper way? I know we could hack up some ourselves, but I'm sure there's already like an existing bit of code that only runs when you go from invincibility to stars. It's just the last thing I want to do is have a flag that monitors which one's going on. Oh dear. Well, yeah, there is one idea, but it's not as elegant as I'd like it to be. When the invincibility decides it should go away, I can make it load the shield graphics. But it would be nicer if the shield autonomously knew when to load its own graphics, rather than having someone else deal with it. Same for the stars, really, but the stars are already doing their job. It's the shield I'm stuck on. Like, sure, we could have a check that says, was Sonic invincible? Is he invincible now? No? Okay, load graphics. Just don't want to do that. I mean, when you start getting careless and having state variables everywhere, you run out of object RAM. It's better to take advantage of code flow, like what I suggested earlier, by taking advantage of this. This is code that will only run when it goes from, well, when the stars go away anyway. Oh well, feels like a bit of a hack, but maybe this is what we have to do. Though while we're here, I am curious what that macro... So, source, length, destination. Alright, well, since we're going to be here for longer than I was hoping, let's start using this macro. It's a bit faster and it has some nice security checks built in. So it wants the source, the length, and then the destination. So here's the source, here's the length, and here's the destination. I think... I don't know which format it wants them in. I think that's how the syntax is. Okay, clearly I'm using this wrong. Do I need commas? Ah, okay. So as I said, this DMA queue is intended for Sonic 2 and 3, not 1. So it's using some features from that disassembly that we don't have in Sonic 1. Let's quickly pluck it from Sonic 2, shall we? It's in one of these macro files. I'm going to go with this one. Here we go. Just going to want to take this. It doesn't look like it relies on any other macros. Wait a minute. I bet it's using all kinds of other things. Unless it defines them. Whatever. Let's just... Well, I suppose I can put it in here? Maybe? Just thinking of what's a good place to keep them. Look like it, yeah, it built. Pop open a VRAM viewer. You know, I gotta tell you, I'm glad I found this emulator. For the longest time I used Regen, which is horribly outdated, pretty inaccurate, and its VRAM viewer doesn't even show you all of VRAM. This bottom bit's missing. Alright. So again, we're going to grab a shield, get the invincibility, then watch it wear off. Hopefully we got it right first time, because I'm, well, rather not keep pedantically editing my code over and over again to fix tiny typos. It's not the most interesting thing in the world. Okay, it's working. As you can see, it's no longer filling VRAM with garbage because we have a proper length defined. These stars have loaded properly. Yep, and the shield loads back in properly. Okay, well, I think we're done with this video, and I think this video is shorter than the others. Thank God. Alright. So with that, we now have freed a bunch of VRAM for on-demand art loading, which is ideal for the elemental shields, which use a similar system to this. The only difference is rather than loading all of their art at once, it streams each frame of animation to VRAM, which incurs significantly less VRAM usage at the cost of some performance and bandwidth penalty. Alright, and with that said, I don't believe, there really is anything else to do. So, see you in the next part, where we will hopefully be implementing the actual shield objects, this thing. Implementing the graphics, and then in the part after that, audio. So see you then.